Hey guys, Mrs. Traver here. We're going to do our notes on section 4.4 continued. This time in logarithmic functions, we're going to look at everything but graphing. So in this section, you will convert from logarithmic to exponential form and then back, as well as evaluate logarithms without a calculator. We will use common logs and natural logs as well. So some things to remember. This thing that sounds fancy, this log, it's just an exponent. In other words, it's the answer. The answer to a log is an exponent, so it's going to be the inverse of that, like we talked about last time. We'll look at common logs, which are just special because they have base 10, as well as natural logs because they have base e. And then another thing to keep in mind, you can't take the log of 0 or negatives because of how the exponents work, vice versa. So let's get into the conversions. In this chart, what we'll do, I'm going to zoom in a little bit, is we'll look at this conversion that we'll use a bunch of times, and then we'll go from exponential to logarithmic or back. So here we go. So the exponential form is this one. And then the logarithmic form is this one. So we'll be able to go back and forth with this. Basically what you see is this is normal, y equals b to the x. And then over here our base goes down with the log. The answer, it's like base, log base, base of the answer equals x. Or log base b of the answer equals the exponent, or however you want to think of it. But we'll switch back and forth with these. So the first one's done for us. We had 5 to the second is 25, a fact that we know. And then we took 5 was the base. So that came down here. Log base 5 of 25 is 2. So what it's really saying is 5 to the what is 25 is kind of how I like to think of this. So that's kind of another way to think of these. 5 to the what is 25, and it's 2. So let's look at the next one. 10 to the 5th equals 100,000. So what we're saying is, 10 to the what is 100,000. So we're going to do log base, the base here was 10, so the base here is also 10, of the answer is, let's go back, is x, which was the exponent of 5. So 10 to the what is 100,000, it's 5. Let's look at the next one. 9 to the 1/2 equals 3. So we'll go log base is 9 of the answer, 3, equals 9. So 9 to the, 1/2. Getting a little ahead of myself. 9 is the answer to 3 to the what. So 9 to the what equals 3. 9 to the 1/2 is the square root of 9. So that one checks out. Remember, this is like square root of 9 equals 3. So these are all connected. All right, let's go the other way around. So in this case, the base is 8. And the exponent on that is x, which came from the answer. So 8 to the 0 equals 1. That checks out because anything to the 0 is 1. This one, the base is 7. 7 to the answer, 3, equals 343. And that one also checks out. So notice there's kind of a theme here. It kind of connects from the radical notation to the exponential notation to the logarithmic notation. These are all tied together very closely. Let's look at, move my light a little bit. There we go. Let's look at the next set. So down here, we're just going to go some flipping, some more of them. These are all in log form. So rewrite the log form equation in exponential form. So we're always going to have something to the x equals y. So b to the x, so base to the answer, 5, base to the answer equals 32. Base to the answer, 7 to the r, equals t. 20 to the 0 equals 1. So we kind of just have to keep flipping them. So 2 to the answer equals 32. 7 to the answer equals t. 20 to the 0 equals 1. w to the negative 1 equals 2. 5 to the 153 equals a. 2 to the negative 4 equals 1/16. So notice on numbers 1, or I'm sorry, on example 3, as well as example 2 and 4, there were variables at play. So whereas we started with something where we couldn't solve, now if we put it into this form, we may be able to. So like this one, for example, w to the negative 1 equals 2. I could solve for w here. W to the negative 1 is 1 over w. So in this case, w would have been 1/2. This one, I could multiply that out. 5 times itself 153 times. And this one checks out as well. Let's look at the other direction. So we're going to go the other way around. We're starting with exponential. We'll go to logarithm. So we'll go log base 3 to the answer equals 2 the exponent. So always log with the same base. So base of this exponent was x, base of this log is x. Of the answer is always going to be a thing, equals the exponent. Log base 25 of the answer equals the exponent. We'll get good at these pretty quick. Log base a of the answer equals the exponent. Log of the answer, log base e of the answer equals the exponent. Let me stop here for a minute. We'll come back to this because in a moment we're going to look at natural logs. So I'm going to cycle back to 10 and we'll rewrite that in a moment. Last one, log base y of the answer equals the exponent. All right, last bit here. So it says evaluate the expression without a calculator. So we've got quite a few of these to do. They look pretty sketchy right now, but when we put them into exponential form, then they'll be okay. So let's do 9 more of these exponential form. So first, we're just going to switch it like that. So let's see. First off, all of these are filled in, so that's what we're solving for. Let's make them the x's. Okay, so let's see. 3 to the x equals 81. So 3 to the what equals 81? 3 times 3 times 3 times 3. So 9 times 9, which is 3 times 3 times 3 times 3. So it would have to be 4. We're going to have to reason through them like that. This one, 4 to the x equals 16. What to the x equals 16? It would have to have been 2. Next one, 6 to the x equals 1. Well, to get a 1 out, x would have had to be 0. And this one, 9 to the x equals 3. Well, the square root of 9 is 3, so that means x would have had to be a half. Next one, let's see, 512 to the x equals 8. We were told not to use a calculator. Holy cow, I'm going to take a bet that this is 64 times 64. We can do some on the side work to check me, but I'm telling you that's going to work out. So if you were on the side, I would have been doing, this would be a good guess and it'll work out for you. So 64 times 8. So that's 8 to the third. So x equals 3 in that case. 64 times 8. Better multiplication probably do. Next one. So we've got base to the answer 32 to the x equals 2. So how many times does 32 have to get taken to get a 2? Let's see. This is going to have to be a fraction again. So let's see if we can figure out 2 times itself. How many times is 32? Excuse me. Okay. Sorry. Okay, so let's see. 2 times itself, how many times is 32? We would have needed 5 2's. So you can kind of think about a factor tree of these if you're trying to figure them out. And so 32 equals 2 to the 5th. So if 2 to the 5th equals 32, then 32 to the 1/5 has to equal 2. So x equals 1/5. Next one, log base 5 of 0.04. So let's see, 5 to the x equals 0.04. That's 4/100ths, which is 2/50ths, which is 1/20th. And 1/20th is 5 to the what equals 1/20th? Let's see. Oh, I'm sorry. Whoops, 25. 5 times 5 to the 1/2. 5 to the 1/2 would have been, yeah, so x equals 1/2. There we go. All right. We'll need a negative 1/2. Sorry, I had to go back and think about that. So 5 to the 1/2 would have been the square root of 5. We'll need, not that. We want it to be negative, so it'll go on the bottom, and then 2 to make a 25. All right, 2 more. So 0.5, so we'll do 1/2 to the x equals 8. So 1/2 times itself, how many times equals 8? Well, it's going to get smaller and smaller if we multiply, so it's going to have to be negative. And once we make it negative, if we multiply by itself 3 times, we'll get 8. So negative 3. 10 to the what equals 100? Well, we need to square it, so x equals 2. Okay, on to the next set. It says evaluate without using a calculator. A couple more. Let me try to get my light so it's not right in the way. Sorry for the technical difficulties. Struggles with the light still. There we go. Let me just move it closer. There we go. Phew. All right, last 3. Evaluate without a calculator. Log. This one, notice there's nothing down here, so that's going to be a log base 10. So we'd have log base 10 to the x equals 10 to the 6th. Well, x equals 6 in that case, because it already gave it to us. Next one, 10 to the log 5. So let's see, x to the 10th equals log base 10 of 5. X to the 10th equals log base 10 of 5. And then this one here, this 5 out front. Actually, we're going to skip this one for now. We'll come back to it later. That might be an extra credit type of thing. So I will look at that in class with you guys. That is it for these notes. I hope they looked good to you. You're going to have to get pretty good at these exponents in order to carry them out. And we will see you guys next time.